Hello everyone, how are you? I hope you're doing great. This is teacher Amy. For this lesson, can you prepare with you your textbook and your pencil? And can you open it on page 391 to page 396? So you have now your textbook with you. Our lesson this morning is all about find probabilities of compound events. Objectives: organize information about a compound event on a table, a tree diagram, or organized list. Find the probability of an event. Okay, let's have a review. A fair coin is flipped twice. Complete the tree diagram to represent the sample space. As you all know, in a coin, there is a head and there is a tail. So if you're going to flip the coin twice, the first coin, say for example, we're going to start with the head. So what will come here in our first box? Exactly. You can have the head and you can have the tail. How about this one? Yes, of course, it's a tail. So therefore, the outcome will be head and tail.
Talia is playing a game in which she must choose option 1 or option 2, and then spin the game wheel, flip the coin, and roll the number cube labeled 1 through 6. For her to win a prize, all the conditions listed under the chosen option must occur. Which option should Talia choose? Explain.
Okay, so you have option 1, the game wheel lands on S, the coin lands on tails, an even number is rolled. Next, the option 2 will have the game wheel lands on Z, the coin lands on either side. The number 3 is rolled. So our illustration will look like this. First option, you will have in the S, you have the head and the tail, and then an even number is rolled, so you'll have 2, 4, and 6. It lands on the tail. So we're needing the outcome on 2, 4, and 6 in the tail. Next, the option 2 will have Z. The coin lands on either side. So both the head and the tail is needed. The number 3 is rolled. So we're going to circle the outcome 3. So if you are going to choose which option, is it option 1 or option 2? So you'll have Talia should choose option Y because there are 3 winning combinations and option 2 has 2 winning combinations.
How can a model help you find the probability of a compound event? Think about this question during the lesson. Sadie has 1 ticket left at the school fair, and she hasn't yet won a prize. She decides between 2 games. Which game should she play? Let's think about how we calculate probability. Does having more possible outcomes make it more likely or less likely that Sadie will win? For our first step, let's focus on the game Flip to Win. We can use a table to determine the probability of winning a prize playing Flip to Win. The first flip will be either heads or tails. The second flip will also be either heads or tails. So there are 4 possible outcomes. And there's 1 favorable outcome, 2 heads. What is the probability of winning a game of Flip to Win? Divide the number of favorable outcomes by the number of possible outcomes. The probability of 2 heads is 1/4, or 25%. Now, let's use a second table to determine the probability of winning a prize playing Flip and Spin. Spinning the spinner has 4 possible outcomes, red, yellow, blue, and green. Flipping the coin has 2 possible outcomes, heads and tails. Our table shows each of the 8 outcomes of this compound event. Only 1 of the 8 outcomes is favorable, meaning there's only 1 way to win a prize playing Flip and Spin. This outcome is blue on the spinner and heads on the coin flip. The probability is 1/8, or 12.5%. Now we're ready to compare the probabilities of winning each game. The probability of winning a prize at Flip to Win is 25%, while the probability of winning a prize at Flip and Spin is 12.5%. Sadie is more likely to win a prize playing Flip to Win, so she should use her last ticket to play this game. Now you know how a probability model, like a table, can help you find the probability of a compound event.
I hope example number 1 helped you understand how is the table being used in order to solve the probability of a compound event. So let's gonna try to answer this. Try it number 1. So we have
The designer of Flip and Spin creates a new game using a 5-section spinner as shown. How does the new spinner change the probability of winning a prize?
okay, so you will have how would the table in step 2 change to accommodate the new spinner choice? So you will see there would need to be 5 choices along the side instead of only 4. The color orange would also be needed to be included. And James says that the number of outcomes will change from 8 to 9 since only one color is added. Do you agree with this one? So you will see James here is incorrect since the number of outcomes increases by 2. Even though only one color was added, the outcomes orange heads and orange tails were both added. So using the 5-section spinner, the probability of winning a prize is, okay, so you will have 1 over 10 or 10%. How did you get 10%? By just dividing 1 to 10, you will have 0.10. Change that 1 to percent, your answer is 10%. So it is blank likely that the player will win a prize when the 5-section spinner than when using the 4-section spinner. So it is correct. It is less. So let's proceed to example number 2. As you will notice there are 3 flips. Flip 1, flip 2, and flip 3. Why are there 2 coins at the top of the 3 diagram? The top one. Why? Because the 2 coins represent 2 possible outcomes of the first time the coin is flipped. What does the second row of the 3 diagram mean? After the second flip of one coin, there are possible combinations. You have the HH or HT if the first flip was heads, or TH or TT if the first flip was tails. So you can see in there, the probability at exactly 2 heads is equals to 3 over 8 in the third flip. So that is 37.5%. So each of 8 outcomes is equally likely. 3 of the 8 outcomes are favorable.
Is it more likely that a coin flipped 3 times will land heads up exactly once, or will land heads up exactly twice? Explain using probability.
Okay, so for this, trying it number 2, for the probability to be same for both situations, what must be true about the number of favorable outcomes in each situation? So you will see there the number of favorable outcomes must be the same. So therefore, it's neither. The probability of each event is 3 all over 8.
The names of all middle school students with perfect attendance are entered into a drawing for one of 2 tickets to a baseball game. This year, Angie, Phil, Mark, Carly, and Josie attended school every day. What is the probability that Mark's name will be drawn to win one of the 2 tickets?
Okay, so let's have an organized list of possible outcomes for the winners of the 2 tickets. So the first one is you have Angie and Angie. So Angie will be paired to the rest of the 4, Phil, Mark, Carly, and Josie. Then the next one, Phil. So he will be paired to Angie, Mark, Carly, and Josie. Next, the third one, Mark. He will be paired to Angie, Phil, Carrie, and Juicy. Next, Carla. So 4 are left, so pair that one, Angie, Phil, Mark, and Josie. Next, the last one is Josie, paired to Angie, Phil, Mark, and Carla. The question is asking for the probability that Mark's name will be drawn. So you will see the green one here. Notice that first one, Angie and Mark. Second one, Phil and Mark. Then the last one, Mark, Angie, Phil, Carrie, and Josie. And you will have Carrie and Mark, Josie and Mark. So which of these tables contain the name of Mark? So you will have, by merely counting, you will have 1, 2, 3, 4, 5, 6, 7, and 8. So that is our possible outcome. So therefore, you will have our probability here is 8 over how many all combinations, possible combinations? You have 20. So 8 over 20, that is 40%. So let's have this try it. Try to observe on example number 2. Does Mark have a greater chance than Carly of winning the tickets? Explain using probability. So we have there, based on the organized list, the probability that Mark or Carly will win a ticket is 8 over 20 or 40%. So they have the same. I hope you understand something with our lesson this morning using a tree diagram, a organized list, and a table. So you will see that the probability of a compound event can be represented by the ratio of the number of favorable outcomes to the total number of possible equally likely outcomes. So you have the list, a table, or tree diagram to determine the number of favorable outcomes and the total of possible outcomes. I hope you learned something from our lesson this morning so that we can proceed now on page 394. Please be with me. Question number 1. How can a model help find the probability of a compound event? Our answer is, a model can represent the sample space, and the sample space can be used to determine the probability of an event. Question number 2. What do you know about the outcomes of a compound event displayed in an organized list table or a tree diagram? Our answer is, each model shows the complete sample space of a compound event. Question number 3. How does finding the probability of a compound event compare with finding the probability of a simple event? So these two, compound versus simple event. So our answer would be, you can find the probability of both simple and compound events with the ratio of the number of favorable outcomes to the number of total outcomes. I hope you're still with me. So let's proceed to question number 4. Look carefully the following given. You have Pedro, Whitney, and Brian. What is the probability that Whitney will win prize 2? Okay, so you'll have, it's 1 over 9. Next, for this number, question number 5, the table shows all the possible outcomes for flipping a coin and spinning the pointer of a spinner with 4 equal size sections labeled 1 through 4. So you have their heads 1 up to 4, and the tails also you have 1 up to 4. Now the question is for letter A, what is the probability that the pointer will stop on 3 and the coin will land on heads? So what you're gonna do? The answer is, yeah, probably it's 1 over 8. And letter B, our answer would be 2, 8, or 1 over 4. So let's have question number 6. A fair coin is tossed twice in succession. So you have toss 1, look at the table, and you have toss 2. So there are blank outcomes that have exactly one tail. How many outcomes that has exactly one tail? 2 outcomes. There are blank possible outcomes which are equally likely. How many possible outcomes? Let's count 1, 2, 3, and 4. So therefore, exactly one tail. So what you will do, 2 over 4, convert that 1 to percent, you will have 50%. Okay, so I hope you're still with me. So let's proceed to number 7. In number 7, you have there the tree diagram, which shows the sample space of a two-digit numbers that can be created using 2, 6, 7, and 9. So there are blank outcomes that includes both 9 and 6. So look at here, 9 and 6. How many outcomes includes 9 and 6? Look at the tree diagram. Look at its branches. So you'll have 2, correct. So there are blank possible outcomes which are equally likely. So we will count starting at 2 to each branches. You will see each of them, 2, 6, 7, and 9, each has 3. So 3, 6, 9. You have how many possible outcomes? Yes, you have 2 over 12. So therefore, our probability on 9 and 6 is you will have 2 over 12, which is 16 and 2/3%. Number 8. In this problem, as you will see there on the right, okay, spinning the spinner and flipping a fair coin. So you have there 1, 2, 3, 4, and 5. The question is find the probability of a coin that lands on the up head and a pointer landing 1, 2, and 4. So what you're gonna do, you're going to analyze the table. So find this number 1, 2, and 4 with the corresponding pair ahead. So how many? What is the probability then? And what is the possible outcome? So you will have exactly 3 over 10. How did we get 10? So by just merely counting all of them. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Of course, the possible combinations of 1, 2, and 4, you have only 3 over 10. Okay, in this problem number 9, you are asked to answer the following. What is the probability of two fair coins that lands heads up when three are flipped? Okay, what do you mean by heads up? Most of the items contains only heads. So you will see possible combination. You have 1, 2, 3, 4. So therefore, what is our answer? You have 4 over 8. How many all? 1, 2, 3, 4, 5, 6, 7, 8. So 4 over 8, which is 50%. For problem number 10, Gary spins two game wheels at the carnival. He will win a prize if both of the wheels land on any red section. How does the chance of winning games if different game wheels are used with more sections that aren't red? So our answer is Guard chance of winning is the ratio of the number of favorable outcomes, which is 9, to the total number of possible equally likely outcomes, 225. So he has, what you will do, you'll have 9 over 225, which is 4% of the possible chances of winning. Thank you very much for patiently listening and studying, everyone. Have a good day.